30 seconds. 20 seconds. 10.
11 a.m., missile fired at Woomera, the Australian guided weapon range. Every observer on the job, downrange and at the range head. A missile flight may last only for seconds, but every hundredth of a second tells an important story. The details of that story are automatically recorded on film, paper, and magnetic tape. The records are sent back 300 miles from the Woomera Range to the laboratories at Salisbury, South Australia, headquarters of the Australian Weapons Research Establishment. Here, every inch of film exposed is developed and prepared for evaluation. The staff at Salisbury is a team experienced in their job, which is to analyze and combine records to produce a simplified, complete report of missile performance. The report is quantitative, figures on paper, curves on a graph. The story of the trial is built up bit by bit, but quickly. Pictures of rockets taken by special cameras are examined to get information on missile position and behavior during flight. Figures are mechanically transferred to the coordinates of a graph. Some of the record is in the form of holes in punch cards. The system is being superseded in the establishment, but it is still used for certain computations. All missiles fired at the Woomera Range carry instruments which radio signals give flight information to a recording station at the range head. The system is called telemetry. The tape on which the signals are recorded is processed to extract each component of the information. RAAF, Weapons Research Establishment Digital Automatic Computer, is one of the electronic computers which works at the rate of thousands of multiplications and additions per second. This mechanization means that calculations which only recently took 120 hours to complete are now finished in half an hour. An output machine produces graphs and tables which can, if necessary, be torn off and passed directly to the sponsors of the trial. Most missiles tested on the range are from the United Kingdom, made by manufacturers under contract to the British Ministry of Supply. When reports are completed, copies go to the contracting firms and to the Ministry. Weapons Research Establishment headquarters at Salisbury is in the open country 16 miles from Adelaide, capital of South Australia. The whole area is 7 square miles inside a security fence. Where so much work is secret, all movement into the site must be by security pass. By agreement between the governments of the United Kingdom and Australia, the establishment was created to provide a 1,250-mile land range for testing guided weapons developed by United Kingdom manufacturers. The Missile Project Group is the link between the establishment and the British contractors carrying out trials. A complete section of buildings has been set aside for the contractors. Here they receive the missiles from England, carry out assembly, final tests and modifications, and prepare the internal instrumentation for the firing on the Woomera Range. As well as the facilities for recording and analyzing the performance of missiles, the establishment provides contractors with premises which they can equip to serve their needs. The establishment has its own workshops and laboratories. In the electronic section, technicians weave the complicated wiring patterns of the guided weapons and the machines that control and record their movements. When men can be spread miles apart over the range during firing, communications are most important. A special section builds and maintains the equipment needed. In the chemical laboratory, scientists experiment with the composition of rocket fuels. Spectroscopic analysis helps research into materials for rocket motors and nozzles. Further information about rocket motors is provided by static firings where the rocket cannot move.
5, 4, 3, 2, 1.
The wind tunnel for work on the aerodynamics of supersonic flight gives speeds up to a Mach number of 2.8 in a working section 15 inches square. The establishment's own scientists are working on research programs in aerodynamics, propulsion, and electronics. AGWAC, Australian Guided Weapons Analog Computer, is used for general-purpose simulation. Problems of guided weapon systems or parts of a system can be analyzed by AGWAC. Where so much observation is done by camera, fine optical work is essential. In the workshops, there are skilled men to make prisms, lenses, or whatever else may be needed. One of the projects in the optical laboratory is the construction of a 200-inch lens for better recording of missiles in flight. In the Cine division, as well as the processing of film taken during missile tests, there is continuous maintenance of the cameras which do much of the recording. Diamond drilling is one of the operations carried out in the fine instrument shop, where the most delicate apparatus is made and serviced to work in missiles, range instrumentation, or the machines that evaluate records. The varied activities of Salisbury are an essential background to the continually changing program of the range, with its trials, instrumentation, and observations. Because of the high cost of maintaining staff at Woomera, as much as possible of the work is concentrated at Salisbury. In the workshops, skilled fitters and turners operate a full range of machines, including some that work with such accuracy the temperature of the room they're in must be rigidly controlled. In the building allocated to one of the British contractors, a guided weapon just brought in by plane from the British factory is assembled and checked for firing. The weapon is known as Fire Flash. It is an air-to-air missile to be carried by plane for attack on aerial targets. When the tests are completed, it will be sent to Woomera for firing. Transport to Woomera can be by road, rail, or air. Takeoff point for Woomera is Edinburgh Field, right next to the industrial area at Salisbury. The field was built for the Weapons Research Establishment and is operated by the Royal Australian Air Force to meet establishment requirements in transport and experimental flying. Royal Air Force personnel are posted to Edinburgh to work on certain projects. Materials for Woomera loading. Planes arriving from England with men, equipment and missiles for test. A Canberra bomber takes off on a WRE assignment. Into the Woomera plane goes the fire flash for transport to the firing range, while a new device for testing may be coming from the overseas plane. An RAF Transport Command Comet lands and taxis in. With the weapon fire flash safely stowed aboard, an RAAF Bristol freighter takes off for Woomera. Edinburgh Field is left behind, and the Salisbury establishment, the pattern of its buildings showing their origin as a wartime munitions plant. The plane flies over Salisbury, the town where many of the WRE staff live. Over Elizabeth, the new satellite town being built near the establishment by the South Australian Housing Trust. And a wide sweep takes in Adelaide, the state capital. Then the Bristol heads northwest 300 miles past St. Vincent's Gulf to the dry semi-desert of saltbush, bluebush, the tough mulga trees, and the small stones people of these parts call gibbers. On to the town of Woomera, with the salt of a dry lake, island lagoon glittering on the horizon. Everything had to be transported here. The timber, concrete, steel, to make a modern town for the scientists and technicians and their families. Coming into Woomera, the plane flies over the technical area and a valiant bomber waiting to take off. Here again, security is strict. No one leaves the Woomera strip without a pass. There are always people on the move, technical personnel coming going, or wives making a welcome return from holiday. 3 times a week, air-conditioned diesel rail cars connect with the train to Adelaide, 8.5 hours away. Even water had to be brought to the area. A pipeline was laid 115 miles to Port Augusta, joining Woomera with the established line to the Murray River, a further 270 miles away. Woomera began building in 1947. Today it is a complete town. It has its problems, but the adaptability of the people, helped by some technical advice, has overcome most of them. Homes come in various styles. Some are prefabricated in aluminium or wood, some are brick. Electricity, water and sewerage are laid on to every house. It can be hot in Woomera, in summer very hot, but most houses are fitted with air conditioning units to cool the air as they draw it in. Cooking is all electric. Rents are fairly cheap. For most people, the slightly higher than city cost of living is covered by an allowance additional to salary. Dad can have his flower garden if he clears out all the gibbers. Tradesmen give good service. The baker delivers bread from the town bakery. Wherever people are, life is what they make it. And the Woomera people seem to have the trick of making it comfortable. There are 3 churches in the town, all built by community effort with some financial assistance from the authorities. Woomera's air-conditioned post office is a showplace, one of the most modern in Australia. The town has a picture theatre and a department store with everything that's wanted. Or if the store hasn't got what's wanted, it'll get it from Port Augusta or Adelaide. All home needs, fresh fruit and vegetables, a new frock for the lady of the house. The hospital has 40 beds, 2 resident doctors and trained staff. Over 800 babies were born here in the last 5 years. The 400 school children get their lessons in air-conditioned classrooms from teachers of the South Australian Education Department. Woomera is a South Australian town, so it operates on the state services, ordinances and laws. For children below school age but above pram age, there's a kindergarten with qualified supervisors and all the fun and games to be expected in a kindergarten. An arboretum has been set up for experiment with trees and shrubs. This work is valuable not only for Woomera, but for all the arid country of the centre. It may lead to new growth in the hard gibber country. Already trees from the arboretum are planted out and growing in the streets of Woomera. And there's a smooth turf on the bowling green. They haven't managed a cover of grass on the 18-hole golf course laid out by the town's enthusiasts, but it's surprising how well they get along with greens, well, call them greens, made of oiled sand. There's plenty of opportunity for relaxation. Everyone can find a sport to suit him. The swimming pool has no trouble getting customers in summer with the nearest ocean over 100 miles away. Girls on the staff of the weapons range make basketball a really willing game. Single women live in hostels in the town. For men, there are 3 messes which provide accommodation for single men and visitors. Security is insisted on all through the area. The bus stop sign reminds men that with no pass, they won't be able to get to work. Buses take people from the town to their working places. Some go to the range head 23 miles out. Others work in the technical area 3 miles from Woomera. Inside a security fence, passes inspected at the gate, technical area is headquarters for the administration of activities arising from the guided weapons program. At the power station, diesel-driven generators provide power for the technical area itself, for the township, and for installations at the range head. Bulk storage is provided for liquid fuels. The administration building houses the men who see to the smooth running of the Woomera organisation. From headquarters building, the superintendent Woomera Range manages the entire area from the township to the range head. Behind the headquarters building is a hangar for fitting guided weapons to aircraft. And this morning a meteor is coming out to take part in the tests of fire flash. An RAAF bomber, a Valiant, takes off for bombing tests on one of the ranges. "23 miles from the technical area, the smooth bitumen road leads to the range head and Ebbets Field. There are a number of ranges for various purposes. The majority of the work is done on the missile range. From the range head instrumentation building, the range stretches roughly northwest for 1,250 miles to the coast. Ebbets Field is the airstrip near the launching area. Sometimes used by planes flying missiles in direct, it is kept mainly as an operational strip for the Jindivik. The Jindivik is a radio-controlled pilotless aircraft designed and manufactured by the Government Aircraft Factory in Australia. It makes a fast target for guided weapons trials, as it will today for fire flash. 20 miles back in the hangar in the Woomera technical area, the final adjustments and checks are being made to fire flash. Nothing must be left to chance in the involved preparations for the experimental test firing of guided weapons. Passed for test, The weapon goes from the hangar to the meteor that will fire it. While it is being fitted and checked, crews at the range head and along the range are moving to position, setting up instruments, getting ready to record the action of the meteor, the fire flash, and the Jindovic. Even when fire flash is in place on the meteor's wing, there are further checks to be completed. Step by careful step, the preparations go on. From the start of its takeoff run, every movement of Jindovic will be controlled from the ground. At Woomera, the meteor, its wing armed with fire flash, rolls down the strip, ready. At Evartsfield, the Jindovic crew tow their craft into position for takeoff. Meteor away. Flags up. The test has begun. Signal for Jindovic. Take off. The Jindovic goes down the strip on its trolley. Ready for takeoff is indicated by a flash, flying. From the range head, the sub-controller briefs the observers who will make records of the test. In their control room at Evartsfield, the Jindovic captain and his crew set the Jindovic on course for the meteor to contact. A large range staff is working on a complicated problem covering hundreds of square miles of sky. The meteor's pilot gets his directions from a controller on the ground. With a plane and target that may be traveling in the vicinity of 400 miles an hour, directions have to be fast, accurate, and quickly understood. These are the moments when the painstaking, skilled work done at Salisbury pays off in accurate recording and quick communication. Attacker and target are moving to position, directed like pieces on a chessboard from the flight control room. The radar screen is one of the reporters constantly giving position and speed of planes thousands of feet above and miles away. Automatic mapping devices show the tracks of the aircraft above the range. Finally, the Jindovic is brought into position for firing. The meteor moves up. Test successful. As soon as the missile is fired, a recovery party goes out after it. The helicopter takes off. They have their directions from the controller. The ground party sets out from the range head, taking trucks to carry the missile back. Firing completed. Records unloaded for dispatch to Salisbury for evaluation. The director of the recovery party keeps in touch by radio with the range head and the crew of the helicopter. In spite of the huge area of the range, the location of missiles is so effective that very few are lost. Examination of the spent round can add still more to the story already told by the recording instruments. A large launcher at the range head has been built for the rocket Skylark. Final adjustments to the rocket head are completed in one of the test shops near the launching site. One of these shops is usually allocated to each major project for final checkout. With the head of the rocket gone to the launching site, the body is carefully moved to a truck for transport. The complete rocket weighs 2,500 pounds. The firing of a series of these rockets is part of the Weapons Research Establishment program for the International Geophysical Year. The head of the rocket goes into position in the launcher first. When fired, Skylark may go 100 miles upwards into the realms of rarefied atmosphere. With the head in position, the body is steered into place. Skylark will carry instruments designed to radio back information about atmospheric conditions at great altitudes, temperature, density, ionization. It is hoped that the rocket will provide scientists with information about problems of long-range weather forecasting, flight in the stratosphere, and the effect of sunspots and cosmic dust on radio propagation. The steel launcher is more than 80 feet high, built so that it can direct the rocket on the set course. With the body in place and the head fixed to it, the rocket is ready for firing. But the rocket itself seems only a small part of the story. All over the range, observers are getting ready. Skylark will be under close observation for every moment of its flight. The covers slide back off one of the kinetheodolites established downrange. Operators move into position. Power-operated kinetheodolites are elaborate cameras which record the rocket's trajectory as the operators follow it with the huge 80-inch lens mounted on the top. The observational accuracy is an engineering triumph, but the human element remains important. Other visual observations are made with motion picture cameras running at various speeds, each with some particular function of the rocket to observe. Hand-operated kinetheodolites also make visual records of rocket flight. Some of the instrumentation posts are permanent structures, manned when a firing is to take place. Others are mounted in trucks to be moved to whichever part of the range best suits the purpose of the particular test. Doppler radio equipment measures the position, speed, and acceleration of a missile, which may be invisible to cameras, by measuring the changes in frequency of radio signals emitted by the rocket as it goes. Radar can also follow a rocket which is far out of sight. On the roof of the instrumentation building at the range head, a battery of aerials, each designed to receive particular signals, scans the range and the sky above it. Most of these are part of the system of telemetry, the rocket telling its own flight story by radioing back signals. Telemetry takes many different forms according to the information wanted and the methods used to get it. Some information is shown on oscilloscopes, recorded on magnetic tape. Some is recorded by automatic pen reporters on paper. And some by cameras photographing needles flickering on dials. All the records must be synchronized. So, a timing signal is sent from the instrumentation building to be recorded on every film and tape. The controller makes his last check, calling everyone to attention. All reports are in, everyone is ready for the firing. The last men leave the launcher. The sequencer, which will automatically control the firing, is swung into action. The sub-controller calls all observers. Skylark is on its way through the Earth's atmosphere, pressing the limits of the world's knowledge. penetrating further and further into the mysteries of the threshold of space.